So hi, I'm Kelsey. My presentation is about the origin of life on Earth, and in this presentation, I'm just going to give an overview of the early Earth and Right, so hi, I'm Kelsey. My presentation is about the origin of life on Earth, and in this presentation, I'm just going to give an overview of the early Earth and So, the Earth formed about 4.5 billion years ago. This was estimated from radiometric dating of some of the oldest rocks. Earth's atmosphere at this time was mostly inhospitable. It mostly consisted of hydrogen and helium. It was very hot and there was no liquid water. This picture shows a rendition of the early Earth. And it wasn't until this atmosphere was replaced that life could potentially have been able to thrive on Earth. So life arose about 3.5 to 3.9 billion years ago. This was estimated from fossil evidence, and around this time the Earth was beginning to cool and the water vapor in the air was condensing and forming the oceans. So, sometime after this, life was first created. But how? Well, there are several theories. One is the Operin-Haldane hypothesis. This states that life arose gradually from building blocks like amino acids or nucleotides, forming first and then combining to form more complex molecules. Because of the early atmosphere, inorganic molecules could have reacted with energy from the sun or from a lightning strike to form molecules like amino acids or nucleotides. These could have accumulated in the oceans and formed a primordial soup, which could have then reacted and combined and formed larger and more complex molecules. So the Miller-Urey experiment tested this hypothesis by building a system with a heated pool of water and a mixture of gases, like water vapor, ammonia, methane, nitrogen, thought to have resembled Earth's early atmosphere. They sent sparks of electricity through the system to simulate lightning. And after running this for about a week, many types of amino acids, sugars, lipids, and other molecules had been created. However, no DNA or proteins were created. But there's been some speculation if this actually accurately represented Earth's early atmosphere. There's been some debate on the exact composition of Earth's early atmosphere, but there have been many experiments done that show that these molecules can be created under a wide range of conditions. Another hypothesis is the panspermia theory, which states that life originated in outer space and then came to Earth through meteorites or asteroids. This would place the beginning of life at the earlier end of the range, about 3.9 billion years ago. There's a time between 4 and 3.8 billion years ago that the Earth was constantly pummeled by asteroids and meteors, which may have been how life was transferred to the Earth. Scientists found that organic molecules can be produced from simple chemical precursors which are present in space, such as high UV radiation and low temperatures. There are also organic molecules present on other celestial bodies in space. Some evidence for this is some meteorites have been found on Earth with organic compounds that were derived from space. Some even contain nitrogenous bases, amino acids, and other molecules. So there have also been differing theories on what the major molecule was that allowed life to form from all these organic molecules that are present. One theory is the RNA world hypothesis, which believed that RNA was the first genetic material and formed before DNA or proteins. One of the major reasons is that RNA can act as a catalyst, and catalytic RNA could cause a chemical reaction to copy itself, which would pass down genetic information from generation to generation. The other major theory is the metabolism first hypothesis, which states that metabolic pathways were created before DNA or RNA. This would claim that the first life was a self-sustaining network of metabolic reactions. These sorts of organisms could have formed in areas that provided a continuous supply of chemical precursors, like in an undersea hypothermal vent. The first simple pathways may have produced molecules that acted as catalysts for the formation of more complex molecules. So, with all these hypotheses, what did early life actually look like? Well, it was thought to be a self-replicating small organism. The earliest fossil evidence for life was found in Australia, dating back about 3.5 billion years ago. This fossil was a stromatolite, which are layered rocks formed by the growth of single-celled microbes. There were also bacterial fossils found in Australia from about 3.4 billion years ago. So there's been a lot of speculation about how this first life on Earth formed, but we really don't know for sure. The primordial soup and the RNA world theories may be the most popular, but there's been no solid evidence found that completely support one theory or another.